So, the fraud problem has been around for a number of years. In fact, some people call it, second or third business that has ever existed, because whenever there has been a business, there has been a fraud. But the fraud keeps changing. The nature of fraud keeps changing with time and the technology that's available, and especially with the change in the compute stack, change in the compute power, the technologies such as the AI and ML, which are available even to the fraudsters, as we heard in the previous panel as well. The fraud detection area becomes super interesting. And I wanted to start off just asking Fang, what is your perspective on what exactly is fraud? And we also tagged in the label of abuse and waste along with fraud. How do you look at these problems? How do you define them in your context? Because fraud could mean anything to different people, right? So.
Yeah, that's actually a great question. I think traditionally, fraud has been actually a very long-term word that has actually been around for tens of years. Most people think fraud is just transaction fraud. For example, someone's wallet got stolen and they use a credit card to actually go somewhere to buy some goods, go into a gas station. But to today, that's a very narrow sense of fraud. It's only a small portion of fraud. Today, as there are so many apps, there are so many things actually going on the internet, there are a lot of other fraud. For example, you can have everybody, for example, the people actually connect with you, and the emails and sending spam emails, and then there's fake likes. When you see something rank very high in terms of the search engine, that's also fraud. When you buy some apps, and when they actually connect, friends connect with you, want to actually scam you, that's also fraud. And then there are also more severe attacks recently, also because of the things actually going on the internet. Many cases actually our identities are theft, so people are actually applying credit cards, etc., on behalf of the normal users, and they use that to actually conduct fraud. So the fraud notions actually are very much expanded from creating bad accounts to send spams, fake likes, and then to the identity theft part, that actually getting the credit cards or breaching to someone's existing account and to transfer money out, or even write fake reviews and fake likes. And those are all fraud in the sense that, in my view.
Fred, do you want to add anything to that?
Yeah, absolutely. I agree with Fang. The beginnings of fraud are really the beginnings of any time there was a value exchange, whether that was Fred sending Fang $1 or writing a blog post. Anytime there was an opportunity to create value, to create something, there was the emergence of this other group of very highly motivated adversarial folks that wanted to leech from that wanted to take from that. The origins of fraud go all the way back to the origins of commerce and trade, right? This isn't anything new. What is new is the kind of breadth and scope of fraud that we're seeing in the world. As we're talking about, it started with kind of credit card transactions, going into chargebacks, creating fake accounts, and so on. But what we're finding today is that any time there is a button on the internet, anytime there is any value created, a blog post written, a comment, a favorite, a like, those can all be vectors and channels through which fraudsters are attacking either us as individuals or businesses, the clients of our respective companies. And it takes this very broad scale approach of manifestation. It's no longer the case that you can easily say, the reason this happened was specifically for this type of fraud. It is much more complicated.
And it probably also changes with the industry, how you look at the fraud and how it affects the fraud. Is there a difference on say, a shipping industry looking at it versus a bank looking at what is fraud?
Yeah, I think so. So, for Sift, we span many different kinds of businesses, many different types of verticals, and you could say very easily that, financial services, FinTech companies, they're very sensitive to payments types of frauds, account takeovers. Accounts are extremely valuable, as we know. They have good reputations. They're typically paired with billing informations and identities already there. So there's a great deal of value for fraudsters to take on, and therefore these financial services are very sensitive to that kind of attack, an account takeover. But on the other end of the spectrum, you have content and community sites where their entire business is not necessarily driven from high-value accounts from the sense of having large deposits there or billing information, but instead the identity, the reputation, the brand. Imagine you went to Stack Overflow and all you found was really poor quality posts and misinformation and phishing attacks. That tarnishes the brands of this business, and their biggest asset isn't necessarily the number of accounts that have credit cards associated with them, but instead the quality of the writing, the quality of the feedback they get from their audience who reads and subscribes to those posts. So what we found over the years is that there is a very specialized kind of pain that these different verticals feel, and depending on the type of business that they're creating, that pain, that attack from fraud can go in many different ways.
Yeah, I totally agree. I want to add that is that because as different like verticals actually are going on internet, they are also converging. Suppose, for example, you're looking at the banks. Traditionally, most fraud is just like transactions, but now that you have account opening fraud, they have the transaction fraud as well, and they also like loyalty points that actually people can actually get into and use those points as well, and they also have a website, so they can actually create bad reviews and create a list as well on the website, and they can take over. And then all of these are actually connected. Sometimes the banks allowed account to actually connect to other banks or do some other things. So we see attacks that actually from one financial institution attack another financial institutions, and also the even like from social sites to connect to a financial institution, because some of the social sites allowed you to connect to financial institutions, and the connection is actually not through the normal way, because for banks they can be very strict, like how you actually log in, etc. from the web link. But in terms of the back-end connections, because many of them are actually partnerships, it's actually very hard to scrutinize there, because most are actually trying to find these partnerships. So there are attackers constantly looking at all the possible ways that these sites are connected, and they can go through partnerships, they can go through testing links and then developer tools. So the real kind of like protection you need to do is also very changing, because you have a new interface coming up. So it's a very constantly evolving attack to all kinds of online services now.
So Feng, what is the value proposition that ML and AI bring to fraud detection?
Yeah, I think the previous panelists discussed a lot of ML and AI. I think it's a very hot topics now. I think we at the DataVisor, we also use ML and the AI technologies as well. But I want to draw a little bit like a fine line between the security and fraud versus other like image recognition solutions, where like deep learning has a lot of success there. We use deep learning as well, but the main difference from fraud and anti-fraud, anti-abuse, and security is that first, we do not have a very good training data, as APT happens very little, and then when you actually wait for that training, the next thing it actually changed. The second is that attack constantly evolve, and then by the time you train a model, you actually doing rule, these things already change. The third is that the good user behavior is also a little bit like changing. First, it's like image recognition. If you want to recognize this is a car, this is a cat, how the cat look doesn't change over 100 years. You have a cat picture, so you can build a very robust model that actually can last for a very, very long time. For anti-fraud and like this, we need to use AI technologies, but we also need to use a little bit different from the traditional like image recognition. We need to evolve very quickly. That's why we actually use both the supervised and unsupervised, which you are able to identify new attack that's actually happening. And then when you detect things, you need to be very accurate. It's not like the traditional like abnormality detection. I think we talked about abnormality detection in the previous panel. When the abnormality happens, whether it's true fraud or true security attack versus something normal, you have to differentiate from that. That's something that we actually have been working very closely on supervised techniques, but also able to detect things really accurately, not to create too much false positives. Yeah.
Fred, how do you deal with the problem of having the right data set in this world? Because as Fang was mentioning, the types of fraud change dynamically over time, right? Like every day might be different. So how do you come up with the good quality of the data, because the models are as good as the data set, right?
The models are as good as the data set and the volume and the breadth of the data.
Yeah.
There are actually many more factors, but at a very high level, that's what we have found in our experience to be the primary driver of performance and the efficacy of the machine learning approach that we take. So coming back to your question, the way we go about the problem is to define a schema, a language that defines the different types of behaviors, the types of discrete events that in the time series of all actions of all users across all verticals and all businesses and all actions that we can model, and use that to formalize the schema, the lexicon that we can learn on. I think classically one of the really hard problems with machine learning, AI, anomaly detection is dealing with the data. I mean, anyone who's dealt with anything having to do with data knows that data is always very, very impure. There's lots of problems, there's lots of need for normalization and cleansing of that data to put it into a form for any use. And so for us, we took that problem on head on, and we said we have to have high quality data. Garbage in, garbage out. That's just the fundamental rule of, well, it's not a rule, but one of the fundamental adages of computer science, and it is no exception in the world of machine learning. And then I think there's some further kind of nuance and importance here. I think there's this big misapprehension around, if you have good quality data, loads and loads of it, well, you can just throw an algorithm on it and perform well. And I think, again, the practitioners of machine learning, Fang can probably attest to this very, very well, that's not the case, right? You need to use a battery of different approaches, especially in context to your first question, across different verticals, different geographies. The shape and evolution of fraud is varied, and so you have to use a plethora of different models, a plethora of different techniques to really catch this ever-changing landscape of fraud. So even if you have the data under wraps and you have high-quality data, loads of it, you still need to evolve your modeling techniques to keep up with that changing landscape of fraud.
So are there specific techniques that are more amenable in the fraud-based abuse detection?
I think so. I think here getting specific is really important. So for the task of predicting chargebacks, I think this was discussed in the last panel, Fang even brought this up too, is you do get high quality feedback. And it really is best suited for a supervised approach, because if you can be in a position where you get high quality feedback, or you have feedback that you can wait and kind of adapt, because not all feedback is true, as again practitioners of machine learning will attest to, you can drive very, very good performance out of those models. But the nature of the task isn't one where just having one model or a different type of model will tell you, whether you can win or not, or whether you can perform well. That is to say, an unsupervised approach is not worse than a supervised approach, and vice versa. It takes things like that domain knowledge, that ability to iterate and evolve the model, that ability to incorporate that more data, to evaluate it in a principled way. And so for the task of payments and chargebacks abuse, yeah, supervised models tend to work well. They're not the only tool. For other tasks of fraud that we deal with, where we're looking at bodies of text, we use unsupervised approaches like LDA to try and figure out what are the topics here that are being communicated in this text. Let's look at another body of text. Are these things similar? Are there other features in conjunction with these unsupervised features that we've discovered that tell us that these two things are similar? In that task, that particular model and that technique tends to work really well. And so what we found over the years of doing this across all habitable continents and dealing with billions of users is you have to use many, many different techniques, and you have to constantly be evolving and retesting the performance of those models.
Gotcha. You know, a couple of weeks ago, Wall Street Journal had an article which was very interesting in the context of fraud detection. They talked about the e-commerce vendors using fraud detection systems that predicted that a customer who ordered something and said, I want it tomorrow, expedited delivery, they looked at it and said, oh, this is a fraud, and let's stop the shipping of this. And what happened is the end consumer is the one who suffered there, because probably the system failed. Is the machine learning AI system failing for us, or there are drawbacks there, and what's going on?
I think that makes for a sensational title, like to an article. It's definitely the case that again, machine learning is not a silver bullet. You know, it's there's a lot of hype that comes in this space and a lot of misunderstanding. And it's unfortunate, but the nature of the task is one where you will get false positives, you will get false negatives. You know, we deal with sites that you know, will sell diamonds and very high value items online and have very low volume of these, low order volume, but very high value. And then sites on the other end, or clients on the other end, that they sell digital goods. You know, it's extremely high volume, very low value. And really what I'm trying to get at here is that every one of these clients, every one of these businesses, for every type of fraud that they're dealing with, has their own operating point, their own sensitivity to false positives, false negatives being outputted by the model. This story sounds like a very unfortunate case of, if it is a machine learning behind the scenes, being a poorly trained one with insufficient data, either labeled feedback or, you know, rules around the model itself. I don't actually know the details to this, but
sure.
The nature of the beast is one where you have to iterate, you have to have a good sense for how to interpret the results of the machine learning. That's an area that I think is, you know, very, very not well served in industry today, the explainability and the understandability of what those models produce. And if you simply say, well, you know, the expedited shipping signal was weighted very highly and this was his first time purchase, fraudster, you'll get the customer insult. You need to iterate, you need to really invest in the model and understand your data.
Yeah, I think this particular case was actually because many of the normal user behaviors are actually very long tail. If you train like a model and looking at the model with some training data, maybe sometimes we'll just overfit and find a lot of like a hit point. We see this a lot, especially using machine learning, and sometimes more often it's actually using rules, because attacker will actually be very creative. If you set the limit of 500, then we'll do another thing. They will purchase a lot for 499, 498, and 493. So they will actually just keep doing it, and until they find the threshold and conduct attack there. And the most sophisticated attack that we see actually in recent years, and it actually grows a lot, is those attacks that, because attackers, they want to actually gain financial gain as well for all of these attacks. It's mostly financially driven. And they will keep trying to test what's your model look like or your rule look like, when they actually see something actually I can come through, they will actually have a very quick massive attack. In the case that we create a lot of accounts or they actually compromise many accounts. And those are actually usually the hardest one to actually detect in the current situation. And those are the ones that actually drive a lot of like a financial loss as well. And then that's the part that's actually hard. Yeah.
Feng, what do you think about when you are developing systems? What do you think about from a cloud provider perspective? The attackers are probably also using the cloud, and the customers of you are also on the cloud most of the times, right? So how do you think of it? Like, what advice would you provide, either while building the system or on an ongoing monitoring time?
Yeah, so we definitely benefit a lot from the cloud technology because as when we were little, we don't have our own system. Everything is actually on cloud, and we are still actually cloud heavy for many of the things because it helps you scale very quickly if you are actually as a startup. And then using the cloud is actually very important. And then so because we are a little bit specialized in fraud, and then we see a lot of attack actually coming from fraud. So fraudster will, old days they will use Amazons using the digital oceans, and nowadays they start to actually moving a lot to those small cloud providers. Many actually are new, but in our sense, many people actually say there shouldn't be any normal user from all these cloud providers when they're actually coming from cloud provider. Let's block the traffic. But in our study, by looking at billions of users, and we see that it's not every traffic from cloud is bad. It's only like 30 to 40% of the traffic from cloud, and it also varies from cloud to cloud. And some of the new ones, as I mentioned, the small ones, usually they are heavily used by the attacker because they're brand new. Their IP address haven't been got blacklisted yet. The bigger ones that actually have a lot of legitimate use. For example, they will have corporate VPNs on the cloud, and then they also have tunnels on the cloud. There are also a lot of system integrations. For example, one client talks to another a client. Their backend traffic all going through cloud. You cannot say this actually traffic comes from cloud is all bad. That's actually very good traffic. And in some weird cases, we saw some of the even browser. They for security reason they tunnel all the traffic through the cloud. So all the traffic coming from cloud as well. So really, we actually need to be very careful in terms of looking at the traffic where the source is, and to identify what is good traffic versus actually bad traffic. And I see a lot of initiatives actually from the cloud providers. They want to detect what's a part of a traffic from them is actually fraud, because that hurts their reputation, get their IP address blacklisted. So we see a lot of cloud initiative from these cloud vendors. We are working with some of them that actually to help identify the bad traffics from inside, because sometimes when the attacker, they will try to use stolen credit card to sign up accounts. Sometimes they compromise accounts. Sometimes they use the free marketing, the free hours they actually need to. So I think to solve the issue, it should be actually both on the customer side and also the cloud providers that all working together to help solving the issues.
Sure. I have a question for both of you. There are lots of entrepreneurs in the audience. What are the hard problems in the fraud, waste, abuse area that you feel like need attention, are unsolved, where there might be a market opportunity for entrepreneurs to look at?
Do you want to take it first?
Yeah, sure. So what we saw, as I mentioned, the hardest problem is actually those boom, new attacks actually coming on very large. That's what DataVisor is actually specialized in, that we are actually having solutions to identify that. But we also encourage the entrepreneur to actually looking at this problem as well, because that's the hardest one, because these are the new big attack that have a huge impact. Then we use unsupervised solution to identify these, we call it zero-day fraud. But there are also some type of the things actually are harder. For example, there are also fraud, and then I would say like the friendly fraud are sometimes very hard to separate. The friendly fraud in terms of kids use parents' credit cards, and then some people actually they have a good initiative and then later transfer to her. Those are actually, I don't know, it's a very hard area to actually solve, and then it's actually usually the solution is actually very hard to detect these ones now. And then that's also a pain point for some of the merchants out there because they are not able to detect these friendly frauds. So if there's someone who has actually good solutions for these friendly fraud cases, that's also have a big market.
Yeah, I agree with all that. Those are really good points. I think friendly fraud, cracking that nut would be a very valuable one just because it is very, very hard to detect. I think from a more technological approach, really focusing in on the explainability, the reasons why, and having a good solution in the world of fraud. Why is this bad? You know, there's this whole like battery of different approaches that you use to attacking the fraud problem. What's somewhat missing and maybe not as good as it could be is this world of explaining why a model or a system of models and other ancillary tools surface the prediction, the output that they did. And so for the entrepreneurs out there that are looking to kind of crack into the fraud world, I think that would be an extremely valuable advancement, not just for fraud actually, but just all of machine learning and how machine learning is woven together with rule systems and other integrations.
Great, thanks. Let me open up the floor for any questions from the audience.
I come from a healthcare background, and I have a case which has happened at one of our clients' place. I come from a healthcare background. Can you hear me? Okay. So we recently have a case of somebody from Russia trying to peek into a server, which is an EMR server, which means like it has a lot of healthcare data at our client's place. And he didn't know until FBI showed up just suddenly into his office. And these people asked the doctor, and he was like shivering when he heard that FBI is in the office. But what they did is eventually they immediately jumped on that server. They showed that there is somebody who's trying to access the data. And my question is, when they know that there is a particular IP which is trying to attack it, and they showed that there's a traffic coming from Russia from that IP and accessing it, and when they know about that, why didn't they take that action, preventative action, when they know there are certain IPs which are attacking US-based servers and doing all of those things, rather than creating a scene or a situation where not only the doctor got surprised, patients got surprised, but they took the entire snapshot of the hard drive, which has probably much more data than probably those Russian, somebody is trying to take it away, and they took away the entire snapshot of the hard drive. So there is no security or privacy left at the doctor's office who literally owns the data. So it's like two-side question. One is, I mean, somebody could have preventatively, given that kind of security to the infrastructure, which is around there. And the second is the security and privacy of the data.
I'll take that. So I think that there's a couple parts to your question. From the perspective of why were they not able to detect this attacker coming in from Russia sooner, it's a good question. I mean, ideally, that feature, along with the thousands or tens of thousands of other features about that, access would have surfaced that user faster or that attack faster. Without knowing the details, it's hard to comment, but at a high level, I would say that the deployment of machine learning throughout the world is kind of at its beginning. We're beginning to see more and more usage. The growth of the internet, for example, is just taking off. Businesses are coming online. There's more and more use cases that are coming online for existing businesses. And then there are more users using the internet all the time. And so we're seeing the applicability and usability of AI and machine learning techniques go up. And that's slowly starting to crack into like legacy systems and kinds of places like healthcare that are notoriously kind of slow to adopt new technologies. And so what I'd like to think is in that years to come, we'll have, no such case where that would be in the 11th hour or past the point of, meaning for this detection to happen. It could happen before it actually happened. For the second part, for the data privacy, that's a little outside my domain. I think we're beginning to see that with the explosion of data that we're creating, we're going to see more and more regulation and more formal control around how to reasonably use that data. I think as consumers and as the population of the world, we're slowly learning what our data value is. You're seeing fake news, spams, and all this stuff really blow up, and that value is only becoming more clear. Once the value is really crystal clear, I think you'll see regulations and more formal controls over how to manage that data.
There's one last question, maybe.
I come from a more identity security background, fraud. My question in the back of my mind is how much of fraud is really an identity problem? Like if you can just fix the person that you're transacting with and know he who he says it is, wouldn't that solve 90% of fraud or more?
No, absolutely not.
I'm curious what that delta is. And second, I think in the identity space, there's a number of RFCs and technologies that you can sort of drop in and solve the problem. How far are we in the fraud space to getting more as a cookie cutter fraud detection pipeline and then putting it in and solve at least the use cases of interest to me? It seems like there's a lot of black art there, but because there's so many websites that need this, how far is that from reality?
Yeah, so to answer your second question first, it's actually possible that we are actually building to have a generic engine and actually possible, because as we mentioned before, all the fraud cases are different, but in the root, they are all similar in some sense. So it's, to your second question, I think it's possible, even they have different behavior, but you look at its root, it's an account problem. Either it's a badly correlated account or it's actually a account takeover. So account takeover, I think identity solutions can actually help, but there are also limitations on that, because if you look at consumer space, enterprise space, you can say, I force two-factor authentication on every employee. In the consumer space, how many actually of our clients, for example, they send end user willing to actually sign up two-factor? Single digit, and sometimes even less than single digit, because sometimes they even don't do email verification because that hurts your normal user experience that much. That's why the identity solution can work on the enterprise side, probably not too much on the consumer side. And then to the other side of actually creating a better account, some of them actually, because internet is anonymized, and you cannot actually force everybody to sign up an account and to write like a review or have some. You force them to actually give you identity. That's also almost impossible. So in that sense, the identity solutions can help to the enterprise part. Of the consumer part still have a big gap.
Thank you, guys. We're out of time. Thank you, Fred. And
thank you.